Have you ever stopped to consider that the entire world you've ever known, every color, every melody, every joy, every sorrow, has been built for you and you alone, inside the silent, dark space between your ears? It's a strange thought, isn't it, that everything you hold dear, everything you are, is the product of a 3-pound marvel of flesh and electricity. We're not going to treat the brain as a piece of anatomy from a textbook. Instead, I want to invite you on a journey, a slow, gentle exploration into the quiet universe within your own skull. Together, we will discover how this silent, unnoticed command center, this beautiful, mysterious organ, creates every single thought, feeling, and dream you have ever had. Picture this. The organ responsible for your entire reality weighs only about 3 pounds, making up a mere 2% of your body weight. Yet, this incredibly efficient machine is a ravenous consumer of energy. It demands a staggering 20% of all the oxygen and calories you take in. While you sit perfectly still, your brain is humming with more silent activity than a bustling metropolis. It is never, ever off. Have you ever looked at a picture of the brain and wondered about all its wrinkles and folds? That's not random. It's a masterpiece of biological engineering. This folded surface, the cerebral cortex, is a clever design to maximize its own thinking area, packing an incredible amount of processing power into a small space. If you were to flatten it out, it would cover the area of a large pizza. And within this compact space, an entire galaxy of thought resides. We're talking about an estimated 86 billion neurons, nerve cells that act as the stars of this inner cosmos. To put that in perspective, there are more neurons in your brain than there are stars in our Milky Way galaxy. But the real magic isn't in the number of neurons. It's in their connections. Each of these 86 billion neurons can form thousands of links with others, creating a network of over 100 trillion synapses. That number is almost impossible to comprehend. It's more connections than all the stars in thousands of galaxies. This isn't a static circuit board, though. This dense, living network is a self-building ecosystem. It is constantly, quietly reshaping itself through a process called neuroplasticity. With every new memory, every new skill, every new experience, your brain physically changes. It's less like a computer and more like a living, breathing rainforest of thought, constantly growing, adapting, and creating the world you experience, moment by moment. Now, let's zoom in, way in, past the folds and regions, down to the microscopic world where the real work gets done. Here, we find the brain's fundamental building blocks, the celebrities of the nervous system, the neurons. Imagine a forest of impossibly tiny, intricate trees. These are your neurons, each with branches reaching out, desperate to communicate. They don't shout, they whisper. They pass electrical impulses down their trunks and, at the very tips of their branches, release chemical messengers called neurotransmitters. These chemicals drift across a microscopic gap, the synapse, to be caught by the next neuron in the chain, passing the message along. It's a silent, elegant chemical relay race happening trillions of times a second. But as with any great performance, the stars on stage couldn't shine without the tireless crew working behind the scenes. In the brain, these are the glial cells, and they are the true, unsung heroes of this inner universe. For every neuron, there are glial cells working to support it, and without them, the entire system would collapse. Think of them as the brain's tireless support staff. You have the astrocyte caretakers, star-shaped cells that provide nutrients to the neurons, clean up their waste products, and hold them in place. They are the gardeners of the neural rainforest. Then you have the oligodendrocyte electricians. These remarkable cells wrap the long axons of neurons in a fatty substance called myelin. This myelin sheath acts as an insulator, dramatically speeding up the electrical whispers between neurons. Without them, your thoughts would slow to a crawl. And finally, you have the microglial guardians. These are the brain's dedicated immune system, constantly patrolling the neural landscape, searching for signs of damage or infection, and devouring any intruders they find. They are the silent protectors of your mind. So, while the neurons get all the glory for creating our thoughts and feelings, it's this hidden, microscopic workforce of glial cells that makes it all possible. They ensure the brilliant stars of our inner galaxy can continue to shine. Now that we understand the microscopic building blocks, let's zoom back out and take a tour of the brain's larger architecture. The best way to think about the brain's anatomy is as a bustling, sprawling city with different neighborhoods or districts, each with its own unique culture, architecture, and specialized role. Our first stop is the largest and most famous district, the cerebrum. This is the seat of all your higher thought, your personality, your consciousness. It's the Manhattan of your mind. The cerebrum is famously divided into two hemispheres, connected by a superhighway of nerve fibers called the corpus callosum. Popular culture tells us that the right hemisphere is our creative, artistic side, while the left is our analytical, logical side. While there's a grain of truth to this, the reality is far more collaborative. The two hemispheres are in constant communication, working together to create a seamless experience of the world. Within this grand cerebrum, we have four distinct lobes, or neighborhoods, each with a critical job. Up front, behind your forehead, are the frontal lobes. Think of this area as the city's executive suite, the CEO's office. This is where your planning, decision-making, problem-solving, and personality reside. It's the part of you that says, maybe I shouldn't eat that entire cake, or I should probably start that project now. Just behind the frontal lobes are the parietal lobes. This is the city's hub for sensation and spatial awareness. It processes touch, temperature, and pain, and it helps you navigate the world without bumping into things. It's the part of you that knows where your coffee cup is, even when you're not looking directly at it. At the very back of your head are the occipital lobes, the city's visual processing center. Every single thing you see is piped here from your eyes to be decoded and assembled into a coherent picture. And on the sides, near your temples, are the temporal lobes. This district is responsible for processing sound, language, and crucially, forming and retrieving memories. It's the city's library and concert hall, all in one. But our tour isn't over. Tucked underneath the cerebrum at the back is the cerebellum, which means little brain. This is the master of coordination and balance. Every graceful movement, from a dancer's leap to simply walking across the room, is fine-tuned by this silent conductor. And finally, connecting the brain to the spinal cord is the oldest and most fundamental part of our brain city, the brainstem. This is the quiet, unassuming power plant, the keeper of our most vital, automatic functions. It works tirelessly, 24/7, managing your breathing, your heartbeat, and your blood pressure, all without a single conscious thought from you. It's the silent foundation upon which the entire city of your mind is built. Having toured the physical districts of our brain city, we now turn to the energy that brings it to life: communication. A city is nothing without its flow of traffic and information, and in the brain, this flow is everything. It's what transforms static anatomy into dynamic thought. The magic happens through the formation of vast, interconnected webs of neurons called neural networks. The guiding principle here is elegantly simple. A famous phrase in neuroscience: cells that fire together, wire together. Imagine walking through a dense forest for the first time. You have to push through branches and forge a new path. But if you walk that same path every day, soon a clear trail emerges. The connection becomes stronger, faster, and easier to travel. This is exactly what happens in your brain. When you learn a new skill, like playing a guitar chord, a specific set of neurons fires in a specific pattern. At first, the connection is weak and clumsy. You have to think hard about where to place your fingers. But as you practice, again and again, those neurons fire together repeatedly. The synaptic connections between them physically strengthen. The pathway becomes more efficient. Eventually, you can form the chord without even thinking. You've carved a neural pathway. This is how we learn, form habits, and build memories. Our experiences are literally etched into the wiring of our brains. But there's another layer to this dynamic communication. These vast networks don't just fire randomly, they synchronize their activity, creating collective electrical rhythms known as brain waves. If you could see this activity, it would look like a glowing city at night, with different districts pulsing with light in coordinated patterns. These brain waves correspond directly to our mental states. When you're awake, alert, and focused on a problem, your brain is humming with high-frequency gamma and beta waves, the bustling rhythm of a city during rush hour. When you close your eyes and relax, the rhythm slows to a calm tide of alpha waves, like the city winding down in the evening. As you drift into sleep, the waves become even slower and more synchronized, culminating in the deep, slow peaks of delta waves in your deepest, most restorative sleep, the quiet, peaceful hum of a city in the dead of night. These hidden rhythms are the soundtrack to our consciousness, the electrical pulse of the living city within. Now, prepare yourself for one of the most mind-bending truths about your brain. Everything you perceive as the real world is not the world itself. It is, in fact, a seamless, elaborate, and utterly convincing simulation built from the ground up inside your head. Your brain is the ultimate master, illusionist, and you are both its audience and its unwitting magician. Consider the act of seeing. What you think of as sight is really just your brain's interpretation of electromagnetic radiation. Light waves, vibrating at different frequencies, bounce off objects and enter your eyes. They strike the retina, which converts them into raw electrical signals. These signals contain no color, no shape, no beauty. They are just a stream of data, like computer code. This data travels to the occipital lobe at the back of your brain, which acts as a powerful graphics processor. It decodes these signals and constructs the rich, vibrant visual world you experience. The blue of the sky, the face of a loved one, the words on this page. The color blue doesn't exist out there. It's an experience created by your brain. The same is true for all your other senses. The beautiful sound of a piano is not a property of the piano itself. It is merely air vibrations, pressure waves, that travel into your ear. Your brain translates these vibrations into the rich experience of melody and harmony. The delicious smell of baking bread is just airborne molecules landing on receptors in your nose. Your brain creates the sensation of aroma, the taste of a strawberry, the feeling of a cool breeze. All of it is a translation, an interpretation. Each of these sensory streams is processed in its own specialized region of the brain city, the visual cortex, the auditory cortex, and so on. Yet the true genius of this illusionist is how it weaves all of these separate data streams together so flawlessly that we experience a single, unified, and continuous reality. You don't experience sight, then sound, then touch. You experience a single moment, a friend laughing, a dog barking, the sun on your skin, all at once. You live your entire life inside this incredible simulation, this elaborate performance, completely unaware that you are the one creating the show. Every single movement you make, from the grand gesture of throwing a ball to the subtle act of lifting a coffee cup to your lips, is a masterpiece of orchestration, a silent symphony conducted by your brain. We take movement for granted, but the complexity behind even the simplest action is staggering. The process begins in the executive suite of the brain, the frontal lobes, where the decision to move is made. I want to pick up that glass of water. That intention is sent to a specific strip of brain tissue called the motor cortex. Think of the motor cortex as the orchestra's conductor. It holds the sheet music for every possible movement. It sends out precise commands, like a conductor pointing to different sections of the orchestra, down the spinal cord to the exact muscles needed for the action. It signals which muscles need to contract, in what order, and with how much force. Biceps, contract by 30%. Triceps, relax. Now, muscles of the forearm and hand engage to form a grip. But a conductor alone isn't enough. An orchestra needs a master musician to ensure the timing, rhythm, and harmony are perfect. In the brain, this is the job of the cerebellum, the little brain at the back of your head. The cerebellum is the master of fine-tuning. It receives a copy of the motor commands sent from the cortex, and at the same time receives a flood of real-time sensory feedback from your body, information about the position of your limbs, the angle of your joints, your sense of balance. With millisecond accuracy, it compares the intended movement with the actual movement and makes instantaneous corrections. Is your hand moving too fast? Is your grip too tight? The cerebellum adjusts on the fly, smoothing out the motion, ensuring it is fluid and precise. This is how, through practice, conscious effort transforms into unconscious grace. When you first learned to ride a bike, every movement was a conscious struggle. You were actively using your motor cortex to issue clumsy commands. But as you practiced, the cerebellum began to learn the patterns, creating a motor program. The process became automatic. This invisible feedback loop between your cortex, cerebellum, and body allows your brain to constantly adjust your movements. It is a flawless, silent performance that you're watching and conducting every moment of your waking life. Deep within the ancient structures of your brain, hidden from conscious thought, lies a tiny, almost microscopic cluster of about 20,000 neurons. It's smaller than a grain of rice, but its influence is planetary in scale. This is the suprachiasmatic nucleus, or SCN, and it is your body's master clock. It is the grand timekeeper that anchors your entire biology to the 24-hour rotation of the Earth. Located directly above the optic chiasm, where the nerves from your eyes cross, the SCN has a prime piece of real estate. This location gives it direct access to the most important timekeeping signal on our planet, daylight. Specialized cells in your retina detect the presence of ambient light and send a signal straight to the SCN, telling it whether it's day or night. This daily signal allows the master clock to synchronize itself, to stay perfectly in tune with the outside world. But the SCN is more than just a passive receiver of light. It has its own internal rhythm. The neurons within it oscillate on a roughly 24-hour cycle, driven by a beautiful, self-regulating loop of gene expression. Think of it as a molecular pendulum, swinging back and forth with remarkable precision. This internal rhythm is what keeps you on schedule, even in the absence of light cues. Like if you were to spend a few days in a dark cave. From its command center in the hypothalamus, the SCN orchestrates a vast symphony of daily rhythms throughout your body, your circadian rhythms. It sends out signals that control your sleep-wake cycles, telling your pineal gland when to release the sleep-inducing hormone, melatonin. It dictates the rise and fall of your body temperature, your hormone levels, your alertness, and even your metabolism. It's the reason you naturally feel sleepy at night and alert in the morning. It's the reason you experience the disorienting feeling of jet lag when you travel across time zones. Your internal SCN clock is temporarily out of sync with the new day-night cycle. This ancient, internal timekeeper is a steady, invisible tide within you, guiding your entire physiology from the peak of daytime alertness to the depths of nightly rest and back again, every single day. For centuries, we saw sleep as a simple pause, a period of inactivity where the brain and body just shut down. We now know that nothing could be further from the truth. Sleep is not a passive state, but an essential, active, and incredibly complex process of nightly restoration. When you close your eyes at night, you're not shutting down. You're embarking on a vital journey through different worlds of consciousness, each with a critical role in maintaining your mental and physical health. This journey takes you through several stages. First, you drift into the lighter stages of non-REM and REM sleep. Your brain waves begin to slow, your muscles relax, and your breathing evens out. This is a time of memory consolidation. The hippocampus, which has been busy all day capturing new experiences, begins to replay these memories, transferring them to the cortex for long-term storage. It's like a librarian diligently filing away the day's books in the main library. As you descend deeper, you enter slow-wave sleep, the most restorative stage. Your brain waves become long, slow, and powerful delta waves. During this phase, a remarkable process occurs. Your brain cells actually shrink slightly, opening up channels between them. This allows cerebrospinal fluid to wash through the brain tissue in a process recently named the glymphatic system. This system acts like a gentle tide, clearing out metabolic waste and toxic proteins like beta amyloid that accumulate during the day. It's the brain's nightly cleaning crew, and this process is crucial for long-term brain health. Then, after cycling back up through the lighter stages, something incredible happens. You enter REM sleep, the world of vivid dreams. Your brain activity suddenly looks almost identical to when you're awake and alert. Your eyes dart back and forth behind your eyelids, rapid eye movement. But your body is paralyzed, a safety mechanism to prevent you from acting out your dreams. This is the brain's private theater, a time for emotional processing and creative problem solving. While the logical parts of your brain take a backseat, your emotional and visual centers run wild. All the while, your body is busy with physical repairs, and your emotional balance is reset, preparing you for the challenges of the day ahead. Sleep is not lost time. It is the essential maintenance that allows your mind and body to function at all. When we enter the strange and vivid world of REM sleep, the brain transforms. The logical, analytical part of our mind, the prefrontal cortex, our inner CEO, goes quiet. Its grip on reality loosens. This allows the more ancient, emotional, and visual centers of the brain, like the limbic system and the occipital lobe, to run free. It is in this state of creative anarchy that the brain becomes a master storyteller, weaving the surreal narratives we call dreams. But why do we dream? This remains one of the greatest mysteries in neuroscience. But several compelling theories offer clues. One leading idea is that dreams are crucial for memory consolidation. As the brain sorts through the day's events, it doesn't just file them away, it integrates them. Dreams might be the brain's way of connecting new memories with old ones, finding patterns, and strengthening the neural pathways for important information. The bizarre nature of dreams could be a side effect of this process, as the brain searches for unlikely connections. Another theory suggests that dreams are a safe space for emotional rehearsal. They allow us to process the intense emotions of the day in a protected environment. Had a stressful argument? Your dream might be a surreal replay, allowing your brain to work through the feelings of anger or anxiety without real-world consequences. It's a form of overnight therapy, helping to regulate our emotional equilibrium. A more evolutionary perspective proposes that dreams are a form of threat simulation. Our ancestors faced constant physical dangers. Dreams might have served as a virtual reality simulator, allowing them to practice fight or flight responses to various threats, being chased, falling, facing an enemy, so they would be better prepared if they encountered them in waking life. Finally, some researchers believe dreams are simply a catalyst for creativity. By silencing the logical mind and allowing for free association between memories, ideas, and emotions, the brain can stumble upon novel solutions and profound insights. Famous stories of scientific breakthroughs and artistic masterpieces being born in a dream support this idea. Whatever their ultimate purpose, or perhaps it's a combination of all of these, dreams reveal the brain as a ceaseless, restless creator. Even when we are unconscious, it is busy building entire worlds from the raw fabric of memory and imagination, telling us stories about ourselves that we are only just beginning to understand. We often think of memory as a dusty library or a computer hard drive, where our past experiences are stored as perfect, static files, waiting to be retrieved. But this metaphor is profoundly misleading. Memory is not a static library. It is a living, creative, and surprisingly fluid process. Your brain is not a video camera. It is a time machine that rebuilds the past every time you visit it. The journey of a memory begins with encoding. When you experience something new, your sensory systems send a flood of information to the brain. The hippocampus, a seahorse-shaped structure deep in the temporal lobe, acts as a sort of memory formation workbench. It takes the different elements of an experience, the sight, the sound, the emotion, the context, and binds them together into a coherent memory trace. Later, often during sleep, the process of consolidation begins. The hippocampus replays this memory trace, strengthening the neural connections and gradually transferring the memory to the vast networks of the cerebral cortex for long-term storage. But here is where it gets truly fascinating. When you want to recall a memory, you don't simply pull up the file. Instead, your brain actively reassembles the memory from its distributed fragments stored across the cortex. It pieces together the visual, auditory, and emotional components to reconstruct the event. This act of reassembly is not perfect. It's influenced by your current mood, your beliefs, and even the questions you're being asked. This is why memory can be so fallible. Even more startling is the concept of reconsolidation. Neuroscientists have discovered that every time a memory is recalled, it becomes temporarily fragile and malleable. In this state, it can be subtly altered before it is stored again. This means that the very act of remembering can change the memory itself. You're not just recalling the past, you are subtly rewriting it. While this makes our memories less reliable than we might like to think, a fact with huge implications for things like eyewitness testimony, this flexibility is also a gift. It allows us to learn from our past, to update old information with new insights, and to integrate our life experiences into a seamless and constantly evolving personal story. Your memory is not a record of who you were, but an active part of who you are becoming. If there is one single concept that has revolutionized our understanding of the brain in the last 50 years, it is the idea of neuroplasticity. For a long time, the prevailing belief was that the adult brain was a fixed, static machine. Once you reached adulthood, your brain's structure was set in stone. We now know this is completely untrue. The brain is not a finished sculpture. It is a living garden in a constant, dynamic state of growth, pruning, and reorganization. Neuroplasticity is, quite simply, the brain's ability to change its own structure and function in response to experience. This happens at the level of the synapse, the tiny connection between neurons. As we discussed, when we learn, cells that fire together, wire together. Repeatedly using a neural pathway strengthens the synaptic connections along that path, making communication more efficient. Conversely, pathways that are neglected weaken and are eventually pruned away, a use it or lose it principle that keeps the brain efficient and uncluttered. This isn't just a microscopic phenomenon. It leads to large-scale, observable changes in the brain's physical structure. Every new skill you practice, every piece of knowledge you acquire, physically changes your brain. One of the most famous examples of this comes from a study of London taxi drivers. To get their license, these drivers must memorize the knowledge, the complex, labyrinthine map of London's 25,000 streets. Researchers found that experienced taxi drivers had a significantly larger posterior hippocampus, a part of the brain crucial for spatial memory. Compared to a control group, their brains had physically grown and adapted to the intense demands of their job. This principle applies to everything. Learning to play a musical instrument reorganizes the motor and auditory cortices. Learning a new language can increase the density of gray matter in language-related areas. Even meditation has been shown to cause structural changes in regions associated with attention and emotional regulation. This ceaseless remodeling means that we are never finished beings. We are, at a biological level, constantly in a state of becoming. Our minds are not fixed entities, but are quietly and continuously shaped by the landscape of our experiences, our thoughts, and our actions. Your brain is a garden, and you are, in many ways, its gardener. What you choose to cultivate will determine the landscape of your mind. Beneath the intricate layers of logic, reason, and conscious thought, there lies a much older, more powerful part of the brain, the limbic system. This is the ancient emotional core, a set of structures that evolved long before our sophisticated cerebral cortex. It is the brain's internal guidance system, and it has been steering us towards survival and connection for millions of years. At the heart of this system is the amygdala, a small, almond-shaped cluster of neurons. The amygdala is the brain's vigilant alarm bell, its threat detection system. It is constantly scanning our sensory input, asking the primal question, is this good for me, bad for me, or neutral? When it detects a potential threat, the shape of a snake in the grass, an angry face in a crowd, it triggers a rapid, powerful fear response long before your conscious mind even has time to process what's happening. Working in close partnership with the amygdala is the hypothalamus. This tiny structure acts as the bridge connecting your emotions to your physical body. When the amygdala sounds the alarm, the hypothalamus springs into action, commanding the release of stress hormones like adrenaline and cortisol. This is what causes the physical sensations of fear. Your heart pounds, your palms sweat, your breathing quickens. It's preparing your body for fight or flight. But emotions are far more than just fear. The limbic system is also responsible for feelings of pleasure, anger, disgust, and social bonding. It assigns emotional value to our experiences, tagging them as important or unimportant. This emotional tagging is crucial for learning and memory. We are far more likely to remember events that carry a strong emotional charge. It's tempting to think of our feelings as wild, irrational impulses that we must control with our logical minds. But this view is incomplete. Emotions are not the enemy of reason. They are its foundation. They are an ancient, vital, and incredibly efficient form of intelligence. They provide us with instant, intuitive feedback about our environment, guiding our decisions and motivating our actions in ways that conscious thought alone never could. They are the silent, powerful current beneath the surface of our minds, steering us toward what matters most. Far below the bright stage of your conscious awareness, in the deep, quiet backstage of your mind, the brain is orchestrating a silent symphony that keeps you alive. It is a performance of such complexity and precision that it would overwhelm you to even contemplate it. This is the work of the autonomic nervous system, the unseen caretaker that tirelessly regulates the machinery of your life, managed primarily by the oldest part of your brain, the brain stem. This system operates completely automatically, without any need for your conscious input. Right now, as you listen to these words, your brain is managing your heartbeat, ensuring it pumps blood to every cell in your body. It is controlling your breathing, adjusting the rate and depth to match your oxygen needs. It is regulating your blood pressure, minutely widening and constricting your blood vessels to maintain perfect balance. It is managing your digestion, breaking down your last meal, and extracting its nutrients. All of this and 1,000 other processes are happening seamlessly, silently, in the background. The autonomic nervous system has two main branches that work in an elegant, complementary balance. First is the sympathetic nervous system. This is your fight or flight system. When you perceive a threat or face a challenge, this system kicks into high gear. It accelerates your heart rate, diverts blood to your muscles, and sharpens your focus, preparing you for immediate, intense action. It's the gas pedal. Its partner is the parasympathetic nervous system, your rest and digest system. This system does the opposite. It slows the heart rate, stimulates digestion, and promotes relaxation and repair. It is the brake pedal, allowing your body to conserve energy and recover. Throughout your day, these two systems are in a constant, invisible dance, adjusting your body's resources to meet the demands of the moment. The balance between them is crucial for both your physical and mental health. This constant, hidden partnership, this silent symphony conducted by the ancient parts of your brain, is the foundation of your existence. It is the ultimate expression of the brain as a tireless, devoted caretaker, working around the clock to keep you alive and well. Of all the brain's miraculous abilities, perhaps none is more uniquely human than language. Language is more than just a tool for communication. It is the very code for conscious thought. It gives us the power to structure our ideas, to share complex information across generations, and to connect our individual minds into a collective consciousness. Our tour of the Brain City takes us to two districts that are legendary in the study of language. First, in the frontal lobe, we find Broca's area. Think of Broca's area as the architect of speech, the part of the brain responsible for language production. It takes our abstract thoughts and organizes them into grammatically correct sentences, then coordinates the complex muscle movements of the tongue, lips, and vocal cords needed to articulate those words. Damage to this area can result in Broca's aphasia, where a person can understand language but struggles to speak fluently. Then, in the temporal lobe, we visit Wernicke's area. This is the interpreter of meaning, the district responsible for language comprehension. When we hear or read words, Wernicke's area is what allows us to understand their meaning and context. Damage here leads to Wernicke's aphasia, where a person can speak in long, fluent sentences, but the words are jumbled together without any coherent meaning. These two areas, connected by a bundle of nerve fibers, work in constant partnership to allow for meaningful conversation. But the brain's relationship with language goes even deeper. Language doesn't just express our thoughts. It can actually shape them. The words we have available to us can influence how we perceive and categorize the world around us. This suggests a profound interplay between the code we use and the reality we construct. And perhaps most intimately, language gives rise to our inner voice. Have you ever noticed the constant stream of silent speech that narrates your life? That's your inner voice, a product of your brain's language centers. It's the voice that plans your future. I need to remember to buy milk. Rehearses conversations, worries, wonders, and most importantly, weaves together the continuous story of your sense of self. It is the code of language, running silently on our neural hardware that allows us to not just exist, but to know that we exist. While we may experience the world from within our own skulls, our brains did not evolve in isolation. The human brain is, fundamentally, a social organ. It is endlessly curious about other brains, and it is profoundly shaped by our interactions with them. We are, from a neurological perspective, wired for connection. One of the most exciting discoveries in this field has been mirror neurons. These remarkable cells, first discovered in monkeys, fire not only when we perform an action, but also when we observe someone else performing that same action. When you see someone pick up a glass, a part of your brain simulates that action as if you were doing it yourself. This mirroring system goes beyond just actions. It also applies to emotions. When you see someone smile with genuine joy, your mirror neurons help you simulate that feeling, allowing you to experience a shadow of their emotion. When you wince because you see someone else get hurt, that's your mirror neuron system at work. This is believed to be the fundamental neural basis for empathy, the ability to understand and share the feelings of another. It's how we bridge the gap between our separate consciousnesses. Our brains are not just capable of connection, they actively seek it out and reward us for it. When we engage in positive social bonding, a hug from a loved one, a meaningful conversation with a friend, a moment of shared laughter, our brains release a cocktail of rewarding neurochemicals. Dopamine, the molecule of motivation and reward, makes us want to repeat these experiences, and oxytocin, often called the love hormone or bonding hormone, fosters feelings of trust, generosity, and attachment. Conversely, the brain treats social isolation with the same level of alarm as it treats physical pain. The feeling of loneliness or social rejection activates the same brain regions that process physical injury. From your brain's perspective, a threat to your social connection is a threat to your survival. This ancient wiring underscores a deep truth about our nature. We are not built to be alone. We are built to be part of a tribe, to care for one another, and to find meaning and safety in our connections to other human minds. Creative insight often feels like it comes from nowhere, a sudden flash of inspiration, an aha moment that seems almost magical. But while the experience may feel mysterious, it arises from a delicate and fascinating dance between different networks within the brain. Creativity is not magic. It's a specific mode of brain function that we are all capable of accessing. For a long time, we focused on the brain's executive control network. This is the network responsible for focused attention, logical reasoning, and planning. It's the part of your brain that you use when you're solving a math problem, following instructions, or concentrating on a difficult task. It is deliberate, linear, and goal-oriented. We often assume that this is the network we need to use to solve hard problems. However, research has revealed a second, equally important network, the default mode network, DMN. The DMN is most active when your mind is at rest, when you're not focused on any particular external task. This is the network of daydreaming, mind-wandering, and reminiscing. It's a state where your brain makes loose, spontaneous connections between distant ideas, memories, and emotions. The secret to creativity appears to lie in the interplay between these two networks. When we are stuck on a problem, it's often because our focused executive network is too rigid, trying the same logical solutions over and over again. The aha moment often arrives when we finally let go. We step away from the problem, take a walk, get in the shower, or drift off to sleep. This act of unfocusing allows the executive network to loosen its grip, giving the wandering default mode network the freedom to play. In this relaxed, daydreaming state, the DMN can make surprising and novel connections that the logical mind would have dismissed. It might connect a memory from childhood with a detail from a book you read last week, sparking a new idea. The aha moment is the instant when the salience network, another key player, recognizes one of these novel connections as potentially useful and brings it to the attention of the executive network. Creativity, then, is not about forcing a solution. It's about creating the mental space for these two powerful networks to collaborate, to dance between focused effort and relaxed wandering, allowing your mind to stumble upon the treasures it would never find through logic alone. We have now traveled through the brain's anatomy, its cellular mechanics, its intricate systems for perception, movement, memory, and emotion. But all of this leads us to the final, most profound question of all. How does a 3-pound organ made of water, fat, and protein, a collection of silent, unthinking cells, give rise to the experience of being? How does biology become biography? This is the mystery of consciousness. Consciousness is the quiet, undeniable glow that gives reality to your experience. It is the feeling of the warmth of the sun, the taste of chocolate, the redness of a rose. It is the feeling of being you. It is arguably the most fundamental fact of our existence, yet it remains the greatest puzzle in all of science. Unlike memory or language, consciousness has no single identifiable location in the brain. There is no consciousness center you can point to. Instead, the leading theories suggest that consciousness is an emergent property. It doesn't reside in any single neuron or region, but rather emerges from the integrated, synchronized activity of the entire neural network. Think of an orchestra. A single violin playing a note is just that, a note. A single oboe, a single drum. They are all just individual sounds. But when all the musicians play together, in harmony, following the same rhythm, something new is created that is not present in any of the individual parts. A symphony. Consciousness may be like that symphony. It is the holistic, resonant pattern that arises when billions of neurons fire in complex, synchronized harmony. It is the shimmering surface that appears above a deep, vast sea of unconscious processing. We are still in the earliest days of understanding this mystery. Some theories focus on information integration, others on quantum processes within neurons. But for now, consciousness remains the ultimate frontier. It is a humbling reminder that after all our exploration of the intricate machinery of the brain, the simple, undeniable fact of our own awareness, the feeling of what it is like to be, is the greatest marvel of all. The brain is not a static object that simply finishes its development in childhood. It is on a dynamic, lifelong journey, constantly transforming from the moment of our birth to our final days. The story of a human life is, in many ways, the story of a brain in continuous transformation. In childhood and adolescence, the brain is a whirlwind of rapid growth and change. It overproduces a massive number of synaptic connections, creating a brain of immense potential and plasticity. Then, during adolescence, a crucial process of synaptic pruning begins. The brain starts to trim away the connections that are not being used while strengthening the ones that are. It's like a sculptor chiseling away excess stone to reveal a more efficient and refined form. This is why the teenage years are such a critical period for learning and habit formation, but also why the adolescent brain, with its still developing prefrontal cortex, can be prone to impulsivity and risk taking. In adulthood, the brain reaches a state of relative maturity, but the journey of change is far from over. The process of neuroplasticity continues, allowing us to learn, adapt, and acquire new skills throughout our lives. The brain's major networks become more stable and integrated, allowing for greater emotional regulation and more sophisticated decision making. As we move into older age, some changes are inevitable. The brain's processing speed may slow down, and certain types of memory recall might become more challenging. However, the story of the aging brain is not one of a simple decline. It is one of adaptation and wisdom. The brain continues to show remarkable plasticity, reorganizing itself to compensate for age-related changes. This leads to the powerful concept of cognitive reserve. Think of it as a mental savings account that you build up over your lifetime through education, engaging work, social interaction, and mentally stimulating hobbies. A person with a high cognitive reserve may have a brain that can better withstand the challenges of aging or disease, maintaining function for longer. It's compelling evidence that while our brains may change with time, they never lose their fundamental capacity to learn, to adapt, and to grow. The journey is lifelong, and every stage has its own unique purpose and beauty. For all of its astonishing resilience and adaptability, the brain is an incredibly delicate and complex organ. The silent symphony of its billions of neurons is a fragile one, and when something disrupts the harmony, the consequences can be profound. Neurological conditions can be thought of as misfires or disruptions in this intricate symphony. In epilepsy, for example, a sudden, uncontrolled storm of electrical activity sweeps through a region of the brain, disrupting normal function and causing a seizure. In a stroke, the symphony is interrupted by a sudden loss of blood flow, which starves neurons of oxygen and nutrients, causing them to die and silencing a part of the orchestra. In neurodegenerative diseases, like Alzheimer's, the disruption is slower and more insidious. Toxic proteins accumulate in the brain, like static interfering with the music, gradually damaging and destroying neurons, particularly in regions vital for memory and cognition. The music of the mind slowly fades. These conditions are a stark reminder of the biological basis of our very selves. But even in the face of damage, the brain's story is often one of remarkable recovery and adaptation. Thanks to its enduring neuroplasticity, the brain can often reorganize itself after an injury. Healthy regions can sometimes take over the functions of damaged areas, and new neural pathways can be forged to bypass the site of the injury. Rehabilitation therapy after a stroke, for example, is entirely based on harnessing the brain's power to rewire itself. This also highlights the profound importance of lifestyle choices in protecting our neurological health. These choices act as the quiet guardians of our fragile symphony. Regular exercise increases blood flow to the brain and promotes the growth of new neurons. A healthy diet provides the essential building blocks for brain function. Quality sleep, as we've seen, allows the brain to clear out harmful waste products, and continuous mental stimulation and social engagement help to build that crucial cognitive reserve, making our brains more resilient over the long term. Taking care of our brain is not just about preventing disease, it's about preserving the music of who we are. For most of human history, the universe within our skulls was a complete black box. We could only study it indirectly through behavior or after death. But today, we are living in a golden age of neuroscience. Our ability to see inside the living, thinking brain is transforming our understanding of ourselves in ways that were once the stuff of science fiction. The future of this exploration is thrilling. Technologies like brain-computer interfaces, BCIs, are creating a direct communication pathway between the mind and the outside world. These devices can read neural signals and translate thought into action, allowing individuals with paralysis to control robotic limbs or communicate using only their minds. Companies like Neuralink and Synchron are at the forefront of this technology, which holds the promise of restoring function and autonomy to millions. At the same time, massive global research projects are underway to map the brain's connectome, the complete wiring diagram of all 100 trillion neural connections. This endeavor, far more complex than mapping the human genome, promises to reveal the fundamental architecture of thought and consciousness. These powerful new tools are not just for treating disease, they are changing our understanding of what it means to be human. As we learn more about the neural basis of emotion, creativity, and consciousness, we are forced to confront deep philosophical questions about free will, identity, and the nature of reality itself. But what's remarkable is that the more our tools reveal, the more the brain's mystery seems to deepen. Each discovery opens up a dozen new questions. The journey into our own minds is not one that leads to simple, final answers. Instead, it fosters a greater and more profound sense of awe and wonder at the intricate, living universe we all carry within us. The future of neuroscience is not just about understanding an organ, it is about humanity formally meeting its own mind for the very first time. Our long journey is now coming to a close. We have traveled from the galactic scale of the brain, assess physical structure, to the microscopic dance of its neurons. We have explored the bustling city of its anatomy, listened to the rhythms of its networks, and marveled at its power to create our reality, orchestrate our movements, and tell our stories through memory and dreams. And we've come to see the brain not as a static object, but as a living, changing garden, a fragile symphony, and the ultimate master illusionist. Through it all, one theme has remained constant. The brain is our silent, constant companion. It is the unseen caretaker and the quiet storyteller that orchestrates our entire existence from the darkness behind our eyes. It is the keeper of our past, tirelessly reassembling our memories to give us a sense of self. It is the engine of our present, constructing our entire world from raw sensory data in every single moment. And it is the architect of our future, constantly rewiring itself based on our choices and experiences, arising from silent, biological whispers. It creates the magnificent, colorful, and meaningful world that we experience as our lives. The ultimate lesson from this journey is one of quiet marvel and profound responsibility. The health and vitality of this intricate universe are, in large part, in our hands. The advice drawn from this story is simple, yet powerful. Be a good gardener for your mind. Nourish it with good food exercise, and restorative sleep. Challenge it by learning new things and staying curious, building your cognitive reserve throughout your life. Connect it with others, because our brains are fundamentally wired for community. And perhaps most importantly, be mindful of the thoughts and experiences you cultivate, because they are physically shaping the person you are becoming. As we part ways, I want to leave you with a final question to ponder. Now that you know you are the conscious audience to the most elaborate and personal performance in the universe, how will you choose to experience the show? And if you found this journey as fascinating as I have, please consider subscribing to the channel for more explorations into the mysteries of our world. Your support helps us continue this incredible adventure of learning together.